Hello everyone, it's June 28th. Another crazy day. Uh, Finished work pretty late today and got home and I have to deal with some car registration issue and haven't even eaten yet. But so I want to do this a bit earlier before my brain turns into tofu. So here we are. Let's do this. So we have three tabs open, okay? So one of them concerns about yesterday. I'm actually going to do this later. First, handle today's challenge, and I will do it yesterday's. It's not like challenge. It's just there's another solution. Right? There's another solution I want to see. We have my solution, which is kind of brute force, but with a little bit twist. And we have the priority queue solution, and there's another solution called sorting. So I want to try that one as well. But first things first. Let's do today's challenge. Ooh, hold on. What the hell is this? Reset the code. Okay, queue reconstruction by height. You're given an array of people, which are the attributes of some people in queue, not necessarily in order. Each person represents the ith person of height hi, with exactly ki other people in front who have a height greater than or equal to hi. Reconstruct and return the queue that are represented by the input array people. Returned queue should be formatted as an array queue where qj is the attributes of the jth person in the queue. First in the front. Okay, I don't understand anything. I have to read this again every single time, and so I have to read it more than once. So this is people have hi and ki represents the ith person of height. So the first one is height, with exactly ki other people in front who have a height greater than or equal. So have 0 people in front, have 4 people in front. Reconstruct and return the queue that are represented by the input array. Returned queue should be formatted as an array queue where this is the attributes of the jth person in the queue. Q0 is the person in the front. Okay, person 0 has height 5 with no other people taller. 7, no other people taller. 5 have 2 people taller. 6 has 1. 4 have 4. And 7 has 1 people taller or equal to. So it's a reconstruct. Okay. Let's see. Reconstruct. What do we do? So we have the height, and then we know how many people are in front. So we can take all the zeros out, right? We take all the zeros out. That means have 0 people higher. So we take the 0 out, we can sort them, and that is the beginning, right? That is the beginning. Then what? Then can we always pop out the smallest value here? If you think about it, right? If you're putting a queue, oh no, have 0 people. I can have like 8 0 at the end, which is also valid. So that many people taller than me. Okay, we have that many people taller than me. So 7 0 means we have 0 people taller or equal to me. And then 4 4 means my height is 4. And then we have 4 people with height taller, have a height greater than or equal to me. So that means we have 4. taller or equal to me. And then 5, 2, and 7, 1, and 1 people. Let's sort by height first. Sort by height and by, so we could have 7, 0, 7, 1, 6, 1, 5, 0, 5, 2, and 4, 4. Okay? Now, we have, for the first one, have 0 people higher or equal to me. So that's actually in position. 7, 0 is in position. Now we have 7, 1. 7, 1 is also in position because we have 1 is taller or equal to. 6, 1 is not in position, right? Because we have 2 in front. So 6, 1 has to go slightly differently. Okay, hold on. How long? 2,000. So 6, 1 has to go to, because everything in front, they're taller than me, right? So 6, 1 has to go to this position, insert into that position. Okay, so we say insert. So 6, 1, insert here. And then 5, 0, we have 0. So this has to be at the front, right? Because this is small, right? So if you're not in the front, there'll always be something. So 5, 0 has to go to the front. So I have 5, 0, 7, 0, 6, 1, 7, 1. Now 5, 2, then we pick 2, right? 5, 2, have 2 in front of me. And then 4, 4, we pick 4, 4 here. So would this work? I mean, it does work, but it's like O(n) squared. 2,000. 2,000 times 2,000. But we can try. If it fails, then we figure something else out. Ay, ay, ay. Yeah, that's fine. Let's do, that should be 7. Okay. Pretty sure I missed one day. Oh, no, that's not. That's good. Okay, so this one is, let's actually go for 29. It is for 29. The challenge is for 29, it's not for today. It's for tomorrow. Okay. So my current ideal is brute force, right? Basically, we're gonna first we say people.sort. I want to say key equals lambda tuple, and then we return a tuple 0, but on the reverse, so this is going to be there, and tuple 1. Okay, so we sort that, and then rest, let's say, equals this, right? and we basically say for a top in people, okay, and we say if top 1 is equal to len res.append tuple. Okay. Otherwise, it should be not larger or equal to. Right? Larger or equal to, we'll always do this. Otherwise, that means it's smaller than we just insert into, we just say res.insert. Actually, I don't know the syntax for insert. What is the syntax for insert? A.insert. Do we don't have a 100? Is that how it works? Oh yeah. So insert position. So I think it should be top 1. This is the position, right? Should be the position and insert top. Then when I return res. Ain't gonna be pretty. Pretty sure this is not going to be pretty. Trust me. This is not pretty. But since we only have 2,000 items, I have a feeling that this will actually work. Okay. Let's see. We have people. What's this? Reconstruct and people. Yep. Passed these, but not sure. See if we got lucky. Oh, we got lucky that this solution works. I mean, it works. So this is like brute force, right? So this is more or less brute force. So this is brute force. We sort people by height. And yeah. If heights in descent, if heights are the same, we sort by order in ascent. Right, so the idea is that when the current height is being considered, everyone to the left is taller or equal to the current height. And everyone to the right is shorter to the current height. Thus, the position of the current height can be directly determined by its order. We just need to insert it to that position. Runtime is O(n) squared. And then we have this. Okay, so let's check other solutions. Now we have this solution, and this solution. And I did it 2 times. Wow, it's a New Year's Day this year. Only half a year ago. Man, they recycle the problem too fast. So this is 428. I got a default dict. Whatever the solution is, wasn't fast enough. It's 130. Is insert. Oh, O square login. Yeah. Because this is n log n as O squared. Yeah, now we have the insert. But O squared is more. Height. So for each height, I have all the positions. And then I'll sort of height. And now I sort the positions. And I insert. Yeah, that's the same idea. What's this one? Oh my god, BIT. I am not in the mood for this. Nope. 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 Not in the mood. I'm in the mood for this. Let's see. So this one considered done. Now for this. What was the question again? Minimum deletion to make everything unique. The count unique. Okay. Until it becomes unique. Largest unoccupied number that is less than the current number. Oh, I have this. This is what this memo does. We can store all unoccupied numbers in a list, and then for a particular frequency, find the greatest number in that list, which is less than or equal to x. However, this way is not very space efficient. We need to store all the possible frequencies. That's true. Okay, circumvent the need to have a list of unoccupied by iterating over the frequencies in descending order and keeping track of only the maximum frequency that is allowed. We want to keep it. If it is not unique, we want to decrement it as little as possible. The maximum number of frequency can be converted to. Then we can simply change any duplicate frequency to that value instead of decrementing the frequency one step. I think this is exactly what I have. In descending order, I sorted it. Did I sort in descending order? No, I do ascending order. And then whenever we find someone that has seen before, then we go to the memo to find the previous time. What is the largest value of the previous time? And then we start decrementing there. I feel like this is similar. max allowed, we need to delete the excess characters and add the number. Set or update the max frequency allowed to be one less. So we have a max frequency allowed. Okay, so if it's equal, perfect, then we move on, and the max frequency allowed decrement. And if it's smaller, perfect. It's greater than or equal to the current. We don't need to delete yes. If the frequency we're considering is greater, then we delete the excess character and add the number of data. At each step. We'll update the maximum frequency allowed. But what if we encount and we sort it, right? So once that, then we just decrement. Because the remaining must be smaller. It cannot be bigger. Oh, that's actually, it's similar. Okay, it's similar, but the implementation I think is easier. Let's try it. See, I have the Ghana to do this, but I don't have the Ghana to do the BIT. BIT is always a sorting method from the official solution. All right, so again, we have this, right? I'm going to say nums equals sorted this reverse equals true, and a max frequency allowed just equal to nums 0, right? Rest equal to 0. Okay, so we say for any nums, if n is smaller or equal to max frequency allowed equals n minus 1. Else n is larger than, right? Then rest plus equal to max frequency allowed, no, n minus, yeah. And then max frequency allowed minus equal 1. And then we're going to return rest. Let's see. Does it make any sense? Yeah, this is actually very good. So keep track of a max frequency allowed variable value such that we know at each, no, hold on. Also sort the frequencies in descending order. As we go through each frequency, if it is smaller than the max freq allowed, then we know this freq can be used directly. No deletion needed. However, once we do that, we shall update the max frequency allowed to the current frequency minus 1. This is because all the remaining frequency are smaller or equal to the current one. Thus, the only possible max freq allowed is the current frequency minus 1. If the current freq is larger than max freq allowed, then we must delete until the current frequency reaches max freq allowed. And then we decrement. max freak allowed. So this is O and login, which I actually think this is the best solution among the three. Straightforward. Okay. All right, let's test it first. Oh, it is not correct. Oh my God. Huh. Interesting. $18. This should be 18. I think my understanding of the solution is not correct. Hold on. Let's see. Let's see what happens. Let's print nums. Okay. So n is smaller or equal to yes, and max equals 6. Next one, yes, max equals 5. And next one is 4. Max equals 3. Next one is 4 again. Oopsie doozy. So rest should be 1. And max will be 2. And next is 3. So max will become 1. And then we just have to count every single one. 0. Oh, hold on. Max allow if else. Okay, we should do this. We shall do this. For I and enumerate. Okay. Blah, blah, blah. If not max allow, then we're going to break it. Then we say rest plus sum nums I to the end. Yes. Just when you reach 0, then you don't have to do anymore. Ooh, what the heck? What the heck? Huh? Or I simply just if max allowed, then we do this. Void. Yeah, I think it's just the I stuff that's avoided. Maybe we can quit earlier. It's actually good. How about at I plus 1? No. No. Now I don't know why. Like these two pass, but these will fail. I'm curious. It feels to me it shall be this, but these fail. Let's see what happened. Print nums. Okay. So this one failed. So max is 2, right? And now it is good. Now it becomes 1. Is also good. Now I come out. Isn't I is 1? Oh. So if I has reached the end, you know what? In this case, it actually might be better. We say I equals this, right? And then we say, well, I don't know. I'm not sure. You know what? No. I'll say plus this if I is smaller than len nums minus 1. Else res. How about that? Ooh. Ugly as hell. Nope. Now these two are not right. You know what? Forget about it. Simpler. Yep. It's only. Oh, ooh. It is simpler. Okay, let's see the implementation. Frequencies. I use this. Okay, that's fine. Totally fine. I see what you're doing. That's okay. All right, that's it. That is this problem. We still haven't done this yet. Some other time. All right, that will be it. I'm really hungry. Need to eat. See you guys tomorrow. Adios.